Hey everybody, today we're going to talk about the difference between descriptive statistics and inferential statistics. We've mentioned this just a little bit before in the past, but I want to dive a little more into this explicitly because this sets the tone for the remainder of our lectures. So, up to this point, we've talked only about descriptive statistics. Descriptive statistics, of course, are statistics or characteristics of samples that tell us something about the sample. It's usually something about the shape of the distribution. It could also be something about the central tendency, right? So the mean, median, and mode, for example, are all descriptive statistics. They tell us about a single variable and about some characteristic about that single variable. Additionally, the range tells us about how that variable spans over whatever metric that we're using across that usually x-axis, right? So it tells us just how far that variable is spread out. And then, of course, the standard deviation is a little more clear and gives us a little more information about how that variable spreads out. Specifically, it tells us on average how much these scores deviate from their mean. So it's a very advanced kind of descriptive statistic. And of course, there are others as well. For example, the z-score also tells us that's a descriptive statistic by definition. Okay. Now, descriptive statistics are wonderful. They tell us a lot of things about single variables and help us to understand the shape of a distribution, how the variable seems to behave independently of anything else. So it's very useful, very nice. It's nice to communicate to other people how this variable works. Inferential statistics, by definition, do have more than one variable. In other words, we're addressing at least two variables, and what we're doing with inferential statistics is assessing for patterns in those two variables. In other words, it starts to help us infer if there is a relationship between the two variables, or if we can rule it out. So if, in other words, if there's something going on with one of the variables, we can start to infer that there may be something else going on with one of the other variables. If that is true, we can suggest that maybe they are related. We can start to explore that option here. Now, some inferential statistics are quite limited in how much they can conclude, how much they can infer about relationships, and others are quite good at it and quite powerful. So we'll talk about that a little bit more as we get going, of course, in future lectures. But this is exactly the power of inferential statistics. They're very useful in this way and very powerful. They've changed the world, quite literally. So let me give you a couple of examples just to drive this point home a little bit more. So for example, a descriptive statistic example would use a single variable, right? So let's imagine you've got a business owner who wants to know about her gross income in the month. So one variable, gross income per month. What she can do is collect the income daily for an entire month, and then she has a big set of data. Now with this data, that's fantastic. With these data, that's fantastic. She can now calculate her average income, right? Her average gross income. She can calculate a range. What was the highest and the difference between the highest and the lowest amounts that she made in a month. And of course, imagining that this goes on for the full month, right? I just didn't put it all there. And she can calculate a standard deviation, which of course tells her just how likely it is for her to earn amounts above her mean versus below her mean. So she can now start to plan for things. For example, let's say that she has some kind of budget that she needs to meet. She needs to have a certain amount of income. She can see how likely it is that she's going to reach those goals. Given her average and her standard deviation. That's all very wonderful, useful. She can also compare her own store using z-scores to somebody else's store, as long as she has that kind of information. So descriptive statistics can be very useful. That's fantastic. But what would be more advanced is if she included another variable and collected that at the same time. So I'll just give you one example. Let's say that she is the same business owner, but she now wants to measure not only her daily gross income, but also the age of the patrons. Now, in this case, we'll say it's the average age of her patrons who come in. So in other words, what she might do is do a little survey, people who come in and she just, she writes down how, what the gross expenditure is, and then she also asks people their ages and says, I'm just going to aggregate the data, meaning I'll just use the means here. So let's say that she did that. It might look something like this. So she's got that same gross income data, but now on the same day, she's collected the average age of the patrons. Now this may be very useful information. It may strike you as not really mattering, But let's imagine that she does some statistics, and we'll explain what she would do here later. We'll get into all that. Don't worry about that. The idea here is now she can look and see if there is a pattern between the mean age of the patrons and the gross income that she made on those days. And if she finds an association, it might mean that older patrons are more likely to spend more money, for example, on those days. So that could be very useful. If that turns out to be the pattern, she can try to take advantage of that pattern. For example, maybe she wants to start advertising to older patrons. Maybe she wants to start finding ways to draw in older patrons. She wants to start attracting older patrons if that will mean an increased income. And you might even go so far as trying to avoid younger patrons, for example, although, of course, that gets into some difficult ethical dilemmas, I suppose, and sometimes even legal issues. However, that would be very useful information. So the point is, inferential statistics can be very powerful. They're very useful. In this little scenario, of course, this is just a business model, right? And it has to do with money. In other circumstances, we're talking about medical interventions that may be enormously useful. They could save lives potentially, and things like that. And so inferential statistics are enormously powerful and useful. They help us to determine if two things are related. And it also helps us to rule out variables that aren't actually helping. Like, for example, if you say, hey, I wonder if salt affects somebody's cholesterol, that's great. We can start to assess that using inferential statistics. And if it doesn't, then we can now start ruling that out. But this is where the power of statistics really lies. It's in inferential statistics. All right. And now you can also use many other kinds of variables. If you want to increase the number of variables that you have to 3, 4, 7, 20, that's fine. For example, you might also be interested in ruling out some of those, because let's say that this business owner measured 7 variables or something all at once, and maybe she finds that the age does matter, the average age of the patrons does matter, but maybe the time of day that they visit doesn't matter. Okay, that would be very interesting, because now she can manipulate her hours that she's open. Maybe she just wants to be open in the afternoons and evenings. Well, it turns out that doesn't affect her income, right? It doesn't affect the gross income. So that's fine. She can do it as she pleases. Now, if it did matter, she would have to manipulate the hours her store was open, or at least balance that with the sort of amount of income that she wanted to make. Okay, so inferential statistics can be very informative, very useful. You can probably start using them in your daily life if you are cautious about it, and if you're deliberate about it, I should say. Okay, there are many different kinds of inferential statistical tests that we can do. You could look at all sorts of variables. Like I said, we're just going to do tests with 2 variables for the remainder of this lecture series. That's all I ever talk about in my textbook as well, and all I ever talk about in my introductory statistics courses. Once you have 3 or 4 variables and on, things get more complicated. They're still doable, of course, but we're just kind of baby stepping our way here. So that's what we have to look forward to. Quick look at what we talked about today. So once again, descriptive statistics are useful in simply describing what's going on within a data set. They allow you to assess for patterns within one variable specifically, and they're limited to only that variable, whereas inferential statistics allow us to start assessing for patterns between 2 variables, or among more than 2 variables, if you will. And they're very powerful, very useful. And so the next one that we will talk about is called, or the first one we will talk about is called correlation, and we'll do that next time. I'll see you then.